Всем добрый день. Очень рады всех видеть. Спасибо,
Hello,
что пришли
everybody.
на наш
A
доклад.
pleasure to see you all.
В целом вижу много знакомых лиц.
Thank you very much for
поэтому
attending this
давайте
session.
начинать.
I see so many familiar
Начать хотелось
faces.
бы как раз с представления.
Now I want to
Если
start with
сработает
introductions.
или не
If the whole thing works, and it doesn't seem to.
У меня почему-то не переключает слайд. Сейчас попробую другой презентер.
My clicker doesn't seem to work.
Да, сработало. Значит, другой работает. Собственно, докладчиков у нас будет двое. Начну с
So
представления
there will be
себя.
two
Я
of
как
us
раз тот
presenting. Let
самый
me start by
представитель
introducing
академии,
myself. I'm
который будет
actually a
выступать
member of the
против
academia that
Hardbase.
has been
По
already
своей должности
mentioned.
я являюсь ученым, исследователем.
I am effectively a
В целом
researcher, a
занимаюсь
scientist, if you
исследовательской
like.
деятельностью в области фундаментальной
I've
информационной
been doing,
безопасности и также прикладной уже
fundamental
в течение 10
information
лет.
security
И в
research as well as
2021
applied
году я
security
защитил свою
research for the
кандидатскую
past decade.
диссертацию. То есть это было
And
в
I
России
have
в
a
университете ИТМО
PhD,
и во
so
Франции
I
в
got my
университете Тулуза. Поэтому я
PhD
являюсь
both
и
from ITMO in
кандидатом
Russia
технических наук, и доктором
and the
философии компьютерных
University
наук.
of Toulouse in France.
И также передаю слово Даниилу, чтобы он мог представить себя.
So I hand over to Daniel so
Меня
that
зовут
he
Даниил.
introduces himself.
Я студент магистратуры
I'm
Санкт-Петербургского
Daniel.
государственного университета
I'm sorry, I'm a student of the Telecom University in St. Petersburg.
технологии и системы связи.
So I'm a student of ICT and network systems
22 годика,
in
тоже
secure networks. I'm
я
22 years of age.
исследователей. И
And I also count myself among the researcher community. But now Dmitry takes over.
Определяются как
So
научный
the
руководитель дипломной
relationship I have with Dmitry is that I am his tutor. I am supervising his research. But, we like working together, and we've been running some side projects that we want to cover today. So you will see that our presentation today will consist of 5 parts. The first 3 will be delivered by me, and then Daniel will take over to tell you more about the applied elements of this research and share the results and findings. Without further ado, let's turn to the first part of the presentation. So we'll talk briefly about IoT. I guess this
и работе с этими устройствами.
These 3 letters do not really require much of an introduction, so you do understand that A, they are prevalent, and B, so much needs to be done in order to secure them. But if we do need a definition, the definition will turn out to be fuzzy. When we talk about IoT, we effectively refer to a broad collection of devices that communicate with each other wirelessly, and that enables us to build, distributed systems. That obviously gives rise to so many different architectures, protocols, all types of software with its own security loopholes. These devices, convenient as they are, smart as they are, and they do enable us to proceed faster towards Industry 4.0, have their own disadvantages. So we have this, broad landscape of devices. We, for example, create smart homes or smart campuses, but we also use IoT in critical infrastructure, say in the industry or in the banking infrastructure, where IoT feels like a very convenient and nifty thing to use, but it can be detrimental to security. Given the prevalence of such systems and devices, we do see a lot of malicious activity. So, for example, a smart sensor can be abused by a perpetrator to gain persistence in a home network or maybe an industrial network. And then, he can stop the operations. This can have impact, both financial, and it can even cost human lives. So defending and securing such devices is very important. Devices themselves can be very narrow functionally, but they also often need access to diverse resources. And that gives rise to the third issue that we have, meaning that our capabilities at defending and securing such devices are limited. We cannot really deploy proper encryption, we are limited in terms of memory, and also these devices still need to perform their primary functions. Moreover, the number of vendors producing such devices is mind-boggling. many of such vendors actually go extinct before their devices are retired. So we cannot even patch up their devices properly, we need to reverse engineer them, or we need to buy replacement and so on. And since these devices work together hand in hand and perform various tasks collaboratively, that significantly expands the attack surface. We cannot count on attacks to be isolated. We have to consider the whole landscape. We need to be aware that a particular device being compromised will potentially lead to all the other devices being under threat. If we're talking here about different ways of securing devices, we should probably distinguish between static and dynamic tools. Static refers to cases where we don't really need to sort of interact too much with the device. We can, simply analyze how it's working. I'm showing some examples here, such as, source code analysis or component analysis or configuration analysis. These are all the things we can check. For example, we can check what kind of software this device is running, what kind of firmware it has got, what kind of operating system it supports. We can also check the source code, look for vulnerabilities there, some architectural defects, some errors, address them and make the system stable. Secondly, we can analyze the individual components. That means going to a higher level of abstraction. That means dealing with the interfaces with, the hardware and software elements. So based on what they are, we can actually identify potential threats and attack vectors and consider how they can be prevented without going down to the level of individual vulnerabilities or the ways they can be exploited. That actually is what happens at the configuration level. There we will take information coming from scanners about what kind of software, coming from what vendor it is running. We'll compare it to various, say, Russian or national vulnerability database, check which of these vulnerabilities are actually, relevant, make sure we install updates and patches if they're available, or we look for other ways to address it. Talking about dynamic analysis, which is obviously more interesting. Dynamic analysis, we need to run the device and test it. Obviously, there are, black box, white box, and gray box ways of testing it, depending on the amount of information that's available. In the white box case,
мы идем в сторону некого анализа потоков данных. То есть
we're effectively analyzing data flow, which will tell us what is running on this device, what kind of components there are, what kind of communication is happening between individual modules, maybe hardware modules and the firmware. That's the internal communications. And we'll also be looking at the external communications of this device with other devices, like how it talks to external systems, for example. And this way we'll try to see if there are any flows out there that violate our security policies. If we're talking about other ways of testing, for example, if we know what's running on the device, what kind of data it expects as an input, what should be the output, then we can send specific requests, specific queries, and analyze the responses. So we can actually do security analysis of various versions of AI, because, there are some basic models that don't have too many variables, too many parameters. They can actually be implemented in IoT devices.
И последнее, это, собственно, то, чему будет посвящен данный доклад.
And finally, something that this particular presentation will focus on deals with behavioral profiling. So we have a specific device designed to serve a specific function. So it should be possible for us to create a normal profile for this device, given what we know about its, historic behavior.
Во втором разделе нашей презентации про эти
In the second part of our presentation, we'll be talking about device profiles.
Хотелось бы с некоторого определения.
Here I'm going to start with the definition again.
Профиль — это некоторый набор признаков.
The profile itself is effectively a set of attributes. This is how we effectively describe our devices, or IoT devices in our specific case.
Это
Now, the
процесс
profiling
сбора
process
большого количества данных о
is
поведении
all about
устройства, чтобы мы,
collecting a
собственно,
lot
могли
of
эти
data
данные
about the
превратить в наши
behavior
признаки.
of a device.
И когда мы говорим в нашей работе как раз про
So,
ML-профилирование, то есть
when we talk
применение
about
машинного
ML
обучения,
profiling,
мы имеем в
something
виду,
that obviously
что
requires
на
machine
основе этих
learning,
признаков мы будем
what
не
we
строить
imply
некоторые
is that on the
статистики и
basis of
шаблоны.
these
Мы будем как
features,
раз
we
обучать
will
модели
be
искусственного интеллекта, чтобы
training
эти как
the
раз статистики и
ML
шаблоны
rather
были
than,
зашиты внутри них.
creating
И уже на
statistics
основе
or
ответов
templates,
этих
because,
моделей
the
принимать
ML
конкретные
will
решения.
effectively have those templates and statistics sort of built into it.
И сам процесс профилирования, он
The
позволяет
profiling
решать достаточно
process
широкий
itself
спектр задач.
helps
Первые
us
три из
address a
возможных
broad
задач, они как раз
range of
представлены на
tasks,
слайде.
some
И
of which are
сразу
shown
хочу
in this
оговориться,
slide.
что вот эти задачи мы не решаем. То есть мы
Please note
подразумеваем,
that
что вот эта
this is
задача
not
с
what we are doing.
идентификацией устройства, определением конкретного экземпляра и обнаружением
So,
новых устройств, она
identification of
решается
device
до нашего
types, of
инструмента, и
specific
мы уже используем
devices,
эту информацию для
or
работы
discovery
нашей.
of new devices. We assume that
Соответственно,
all this
при
has been
идентификацию
done
типа
before
устройства мы
we
хотим
come to the
понять, собственно,
stage.
что за устройство есть у нас в сети.
But,
При
for the sake of the
идентификации
discussion, let me
экземпляра это
explain
скорее
that
среди одного типа
device
устройств
type
мы хотим выявить
identification,
это
this
устройство
is
номер один
all
или это
about
устройство номер
identifying
пять.
whether it's like a fridge
Обнаружение
or a
новых
sensor.
устройств это, собственно, если к сети
Contrast it
подключилось
with a
какое-то
specific
устройство, у
device
этого устройства еще
identification
нет
where we
никакого
want to
профиля,
know
мы, в
whether
принципе, не
it's
понимаем,
light
что от
switch
него
number one or light switch number
ожидать.
two. And
Поэтому мы можем
finally,
применять к этому
new
устройству
device
совсем другие политики
discovery and
безопасности и
identification.
заодно,
Like
собственно, мониторить
when
его
we
трафик,
see a
чтобы в
new
конечном
device
итоге
popping up
можно
in the
было бы
network,
такой профиль
we may want
построить.
to apply, the
Вот. А те
strictest
задачи,
security
которые мы
controls to it
решаем как
before
раз
it's properly
в нашей
identified.
работе, это две
What
ключевые
we
задачи
do
информационной
focus on
безопасности,
is, in fact, two
собственно,
key
обнаружение аномалий
information
и
security
обнаружение
objectives.
атак.
One is anomaly
Под
detection, and
обнаружением
the other is
аномалий мы
attack
имеем в виду
detection.
все отклонения
Anomaly
от
detection
нормального поведения. То есть
describes
у нас есть
all
некоторый набор
deviations from the
сценариев, которые
norm.
устройство должно
So
осуществлять,
we have
некоторый
a
набор
set of
сервисов, с которыми
scenarios
оно должно
that are
взаимодействовать,
considered normal for the
некоторая
device,
ожидаемая
a
частота
range of
использования
services that are considered normal
устройства,
for it to
способы
interact,
взаимодействия с
a
ним.
certain
И
frequency of
если мы видим
usage,
что-то, что в
certain
этот
ways
профиль
of using the
вписывается,
device, if you like. So
соответственно,
if
это
something
некоторая
does
проблема.
not
Она
match
может
this
быть как
profile,
связана с вредоносной активностью,
this
так и
may be
нет.
an
Это может
issue.
быть какая-то
It doesn't
поломка,
have to be
ошибка,
related to an attack. It may be a
некорректное
bug. It
использование
may be
устройства
a
и так далее.
failure, or
Но,
it could
опять же,
be
это нечто
improper use of the
подозрительное, на что
device.
уже надо обратить
But in any
внимание, про
case,
что надо
it should
сигнализировать.
raise our suspicions,
Второй
and
момент
an
—
alert
это
should be
обнаружение атак.
created.
Если на предыдущем
Another
шаге
one,
мы
or the
работали
other one
только
rather,
с
is attack
нормальным
discovery.
поведением, строили на основе этого модель и
So
уже детектировали отклонения,
we
то здесь у нас
based
есть
our model
разметка.
on
То есть мы
normal behavior.
понимаем,
And this
какие
means that
виды
we have the
нормального
markup.
поведения у нас
We
есть,
know
что
what
вот
types
этот
of
сценарий
normal
номер один, вот этот
behavior
сценарий
are
номер пять.
characteristic of such a
Мы
device.
понимаем, что у нас есть конкретная вредоносная
So we
активность,
shall know this
некоторые
is scenario number
символы
one,
трафика,
different
как
from
раз
scenario number
соответствующая
5.
этой вредоносной активности на фоне
And
этой вредоносной активности на фоне
we'll also
нормальной,
be
поэтому
able
можем
to
отличить одного от другого.
identify,
И мы решаем
say,
задачу
malicious
классификации.
activity scenarios. So our ML can actually do the classification.
Вот. И если говорить, опять же, о проблемах,
Now, if
которые
we're talking
случаются
about the issues here,
в процессах профилирования, то,
that
во-первых,
can pop
устройств
up during the
очень много,
profiling
и они все
process,
очень разные.
they will be as
То есть даже
follows.
если мы
There
ограничиваем
is a
сетевым
veritable
трафиком,
zoo
то
of
обилие
different
признаков,
devices.
которые можно
Even if
на
we're
основе
talking about
сетевого
network
трафика
traffic
извлечь, оно
alone,
является колоссальным.
the
И
number
заранее
of
мне очень
features
известно,
or
какие
attributes you can
признаки, собственно,
extract
сработают для
is
конкретного
humongous,
устройства,
and we
а
don't
какие
even
нет.
know which
И
attributes
взять
will
какой-то
be
универсальный набор
relevant for a
признаков
particular
и
device and
использовать
which
его для всех
won't.
устройств
It's not like we can
одинаковой
use
эффективностью. Это в
a
целом достаточно
one-size-fits-all
нерешаемая задача.
set
Здесь
of features
приходится во многом подстраиваться.
across the spectrum of
Во-вторых, есть
devices.
динамика
So we
поведения.
have to
То
sort of
есть
adapt.
устройства, они
Moreover,
могут меняться
there
со
will be
временем.
behavioral
У них может меняться
differences.
прошивка,
Surprisingly, devices themselves change over time as they get new firmware, for example.
Или, например, устройство у нас какое-то время простаивало, почти не
Or imagine
использовалось,
that a
теперь мы начали
device has
его
not been
активно
used
использовать,
much,
у него
but
изменились,
now, for
собственно,
some reason, you
паттерны
start using it.
активности,
And this
трафика
means
и
that
прочих
activity
нюансов
patterns and
поведения.
traffic patterns have changed for
Соответственно,
it.
система должна такие случаи детектировать,
And the system should be
определять,
good
что нам
at
необходимо
detecting such
пересобрать профиль,
cases.
переопределить
And
его,
it
отказаться,
should
может,
be
от
able
каких-то
to see
исторических
that we
данных и
need
уже
to
ориентироваться на них.
reconstruct the profile,
Если
discard the
говорить про
historical
обучающие
information.
данные, опять же, чтобы
And
устройство
if we're
полноценно
talking
могло
about the train
проявить
data
себя,
here,
должно пройти какое-то
in order for
продолжительное
the
количество времени.
device,
То есть должны
in order
сработать
for
все
the
необходимые
system to be
сценарии, мы
reliable,
должны
we
на каком-то
need
длительном
to
промежутке
collect
времени
enough
оценить их
information so
динамику,
that all behaviors can
сопоставить
be
как-то
seen,
с временными параметрами, другими
so that,
характеристиками, и
we
уже
can
после этого
draw some conclusions about time dependencies, for example, so that, we can safely claim that we know what the normal usage of the device is. And you know what? With some device types, it's more difficult than with others. In fact, there are some device types where you simply cannot do that at all.
Вот. И, собственно, когда мы уже обсудили с вами, и что такое
Now that we have
интернет вещей, и, в принципе,
discussed
зачем
what the IoT
какие-то отдельные
is
устройства профилировать,
and
давайте,
why we
собственно,
would
поговорим
want to
про
do
то
device
решение, которое мы
profiling,
хотели сегодня
let's discuss the
рассказать.
specific solution
В
that we
целом,
wanted to present
у
here
нас есть
today.
3 ключевых особенности нашего
So there
решения,
are
которые
three
нас, в
key
принципе, отличает от всех остальных.
specific features of
Во-первых,
our
мы
solution that set
работаем
us
на
apart
уровне отдельных
from the
устройств.
competition,
То
quote
есть
unquote. A, our
каждый
system
профиль
runs at the
поведенческий,
level of
он
individual
завязывается на конкретный
devices,
экземпляр конкретного
meaning
типа
that a
устройства,
behavioral profile is
на его
associated with a
трафик, на его
particular
поведение.
device rather than a device
И
type.
при
And
этом
it represents its
мы не
specific traffic
можно
and
рассматривать
its
систему, например,
specific
целиком
usage scenario.
и строить ее поведенческий профиль. Можно строить профиль за пределами системы интернета вещей.
You
Можно
can
спускаться
actually
вглубь
develop
устройства и,
such
например,
profiles
строить профиль
outside
каких-то
IoT
внутренних процессов.
networks, and you can
На
go
данный момент
down
мы
to the level of
ограничены
individual
именно
processes
поведением конкретного
running
устройства в целом.
inside a
Во-вторых, мы
device. But we
работаем
are
только с сетевыми
focusing
данными.
on the level
Понятно,
of
что
specific
много
devices.
чего
We're
происходит
only
внутри
working with the
устройства,
network
потому что
traffic. Obviously,
работают
there is a
различные
lot
системы
happening inside an
логирования.
IoT device. For
Но
example,
мы
there will be
ограничиваемся
logging
именно
happening
внешним
there.
взаимодействием устройства, то есть
But we
рассматриваем
only
его как
focus
некоторый
on
черный ящик,
external
в который есть
communications,
определенный
meaning
вход,
that we treat
из
every
которого есть
device as a
определенный
black
выход.
box.
И зависит от
It
того,
has
как
inputs,
этот вход
it
и
has
выход
outputs.
меняются, мы уже можем
Depending on the changes in
обнаружить
the inputs
какие-то
and the
отклонения
outputs,
от нормального
we
или
can
ненормального
detect
поведения.
deviations from the
И
norm.
применяем машинное обучение. То есть есть
And we
различные
apply
способы
ML.
профилирования, в том
There are
числе
different ways
MIDI,
of profiling.
профили, которые,
You
по
can
сути,
do, for
описывают, как
example,
устройство должно
MUD
взаимодействовать с внешними
profiles,
сервисами
and they
и
will
достаточно
effectively
сжатую конкретную
describe what
структуру,
kind
описанную
of
стандартами.
behavior and
Мы
interaction
немножко
you
от
should
всего этого
expect from
отходим
such and
и
such
как
device.
раз
We are not doing
смотрим на
that.
сетевые признаки. При этом мы не
Instead,
анализируем
we
как-то
are
полезную
monitoring
нагрузку, которая
network
передается в
attributes,
трафике. Нам интересны
and we do
именно
not analyze the
различные
payloads
статистические признаки, которые
transmitted in the
позволят, собственно,
traffic. We
без
care primarily
изучения
about the
внутренности трафика,
statistical features
поэтому применимо даже к шифрованному
or
понять, все ли в
statistical
порядке с
attributes.
нашим устройством.
So, even with encrypted traffic, we should be able to
Самих
see
признаков,
deviations
которые на
from the
данный
norm.
момент мы извлекаем, уже больше 60. При
There are
этом
over 60
понимаем, что
attributes
есть
that
огромное
we
количество
extract.
открытых инструментов,
the
которые
moment.
позволяют, собственно, взять на вход
I guess we
различные
do understand that lots and lots
пикап-файлы
of
или файлы в другом формате,
open source
распарсить
tools
их
out
и
there
получить большое количество сетевых
enable you
признаков.
to deal with the
Но
pickup
читали
files,
ряд
parse
работ
them,
и исследований и комментариев,
extract more
замечаний о том,
features.
что
But
они всегда
we've
работают
read some
корректно,
studies
всегда эти данные корректно
about
извлекаются.
such
Поэтому
tools
для
not
обеспечения
being
некоторой
entirely dependable.
защищенности того, что у нас происходит,
So,
и
in order
понимания всех
to
процессов, мы
provide
написали свой
a
собственный
more
инструмент.
robust solution, we have developed
Но
a
при этом
proprietary
мы
system
никак
of
не
our own.
ограничены этим количеством признаков, то есть на данный момент их
We are
60,
not
в
limited
следующем году,
in
если у нас
this
будет еще один
number
доклад,
of
их уже будет
attributes.
несколько сотен,
So this
поэтому
year
будем
we have
смотреть.
60. If we make a presentation next year, we may easily have
Если
several
говорить
hundred
о
there.
пайплайне взаимодействия с моделями искусственного
If we are
интеллекта, то у
talking
нас
about
он
the
достаточно
pipeline
стандартный. То
around
есть 4
ML, it will
классических
be
шага,
pretty standard. So there
начиная
are
от сбора
4
данных
classic
и
steps here,
заканчивая оценкой
starting
и
with data
тестированием.
collection,
То есть
all the way
при
to
предобработке
assessment
данных мы
and
как
testing.
раз извлекаем
So
те признаки,
in
которые у нас
preprocessing, we
есть,
extract the
расставляем
attributes,
метки, и при этом метки мы расставляем как для
we do the
конкретных
markup,
устройств, так и для
and
различных
we
сценариев их
do this
поведения, чтобы мы
marking
могли как
up
раз
for
для
devices
конкретного
as well
устройства
as
конкретный сценарий
behaviors,
определять.
so that we can identify
Осуществляем
specific
форматирование
scenarios for
данных, чтобы
specific
модели
devices, and we
искусственного
do
интеллекта
data
могли принимать эти
formatting,
данные на вход.
so
И,
that
собственно,
ML models
занимаемся
can
балансировкой
actually
данных с
digest this
помощью
data. And
оверсэмплинга
then
и
we do
андерсэмплинга. В
data
целом,
balancing with the help of
проблема
oversampling and
таких устройств, что
undersampling.
сами не генерируют достаточно малое
The problem with
количество
such
трафика
devices is
нормального
that they do not
поведения.
generate
И
too much
зато
traffic on
при
their
атаках
own.
на эти устройства генерируется колоссальное
But
количество
when
трафика,
they are
потому что, как
attacked,
правило, это атаки
they
на
generate
обслуживание.
shitloads of
Соответственно,
traffic,
здесь
I'm sorry,
приходится,
because
чтобы
most of these
модели
attacks are
захватили, собственно,
effectively
паттерны
denial of
того и
service
другого,
attacks.
заниматься
So we
задачей
wanted to
балансировки.
do balancing here
Занимаемся
to make
подготовкой
sure that
моделей.
our
И
data
давайте,
set
наверное,
is not
сменю слайд,
skewed.
чтобы мне проще было рассказывать. Вот. Да, собственно, чуть более подробно.
So let me tell you how we deal with the data.
Про трафик как раз я уже проговорил, то есть различные собираем как классические признаки сетевого трафика, кто
So we
кому
collect
отправил
both
данные,
the
с какого
classic
порта, по какому протоколу, так и
attributes
различные
of the
статистики,
traffic,
в том
like who
числе
sent
минимальные,
a
максимальные,
packet
медианные,
from
средние
which
значения
port
по различным
using
временным
which
окнам,
protocol, but we
чтобы
also
как раз
collect,
пространство признаков
medians
обогатить,
and
и
averages and so on
моделям,
and
в том
so
числе
forth,
сложным было
to
за что зацепиться и поискать некоторые скрытые
augment
зависимости.
the
Если
feature
говорить
space.
про работу с моделями,
to enable finding more interesting dependencies.
Первое, что мы делаем, это разделяем данные. То есть часть
So
данных
the first
уходит
thing
на
we
обучение,
do
часть на валидацию
is
моделей,
separate
часть
the
данных
data
моделей
so
вообще,
that
в
we use
принципе,
some
не видно,
data
потому что
for
они используются
training,
для
some
тестирования.
for validation, and some data is
Проверяем,
not
чтобы
even
данные
shown to the models
были
because we'll use this
консистентными
data later
и
for testing.
результаты
Then we
стабильными
check
на
data for
различных подвыборках.
consistency
Потом
so that
оптимизируем
results
модели,
are
чтобы у
stable
них
across
были
different
наилучшие
samples, and we
параметры.
optimize
И
the
уже затем
models so
занимаемся
that they have
оценкой
the
и
best
тестированием.
parameters,
Собирается целый
and
ряд
then we do assessment
различных
and
метрик.
testing.
Часть из них покажем
So
как
we
раз в
collect a
результатах
bunch of different
экспериментов,
metrics,
чтобы
some of
оценить,
which we're
собственно,
going
как
to show a
хорошо
bit later, to
модели
show
справляются с задачей
if they
обнаружения
are doing
вредоносной
a good
активности.
job of identifying malicious
Извлекаем
activity.
матрицы ошибок, чтобы посмотреть, собственно, в каких
Next, we
сценариях
create
происходят
error
ошибки,
matrices
и
to
пытаемся понять,
indicate
почему
in
это может
which
происходить.
scenarios errors are
И
most
также
common and
добавляем
why they could
немножко
pop up.
аспекта
And
объяснимости
we also
искусственного интеллекта, чтобы
work
можно
a
было
bit
посмотреть,
on
какие признаки хорошо сработали
explainability
для какого
to
сценария,
see
какие нет, и
which
в дальнейшем,
particular
собственно, ограничивать на основе
features
этого
work best
размерность
in
данных,
which
которые мы
scenario.
используем.
And, that way we
Вот
can,
на этом
in
я
fact,
вводную часть заканчиваю,
manage
и по
dimensionality of the
результатам
data.
экспериментов слово
This is
передаю
where I want
Даниилу.
to stop my introduction and hand it over to Daniel.
Да, я расскажу дальше про результаты наших экспериментов.
Now I step in to
Конкретно в этой
tell you about the
части
results of our
рассмотрим
experiments.
набор данных, которые мы использовали для
Here we shall
экспериментов,
talk
рассмотрим
about the
модели, которые мы
specific data
использовали,
set that we
и
used together with the
посмотрим
models
на
that we
полученные
used.
нами метрики.
And then we'll look at the metrics that we got.
Используемый нами датасет. Мы использовали датасет Канадского института
We
кибербезопасности.
used a data set here coming from the Canadian Institute for
Большое
Cybersecurity.
количество примеров трафика для 20
It contained lots of examples
записи трафика были как
of traffic
и
for
нормального
26
поведения,
devices.
так и атак на
So
эти
the logs
устройства.
corresponded both to normal
Собственно,
behavior
остального
and
у нас,
attacks.
к сожалению, нет, поэтому пришлось
We don't
прибегнуть
really
к
have a
готовому
bench
решению.
of our own, so we had to reuse an existing solution here.
И, как Дмитрий уже сказал, мы
And
написали
just like Dmitry has
собственный
already said,
инструмент парсинга
we
прям
developed
файлов.
our own tool
Этим
for
инструментом
PCAP file
прошлись по
parsing.
данному набору данных,
Then
распарсили
we
пкапы,
sifted on the data set,
добавили
we did the
наш
parsing,
21 признак, посмотрели
then we
на
added
итоговое
21
распределение
features.
данных и пришли к выводу,
We
что
checked out
без
the
балансировки мы дальше не пойдем.
ultimate data distribution, and we realized that we badly needed the balancing. Because with such data imbalance, obviously the quality of
Научиться распознавать мажоритарные
models
классы, но
will
игнорировать
be horrible because the models will be able to identify major classes but not minor ones. So we realized we had to balance the data set. For oversampling purposes, we applied ADASYN algorithm, and for undersampling majority classes, we use random undersampler. That gave us a data set which contained samples of traffic for 26 devices. It had 61 attributes, over 10 million records in total, out of which about 4 million corresponded to normal behavior, and over 6 million were related to attacks,
31 атака — это примеры
including
атак на устройства, те, которые вообще
31
были, потому что датасет
attacks
не на все устройства содержал атаки. В датасете
that were relevant for the devices, because the data set also covered attacks that were not relevant for some devices.
классы нормы 186.
And the number of attacks relevant for a specific device also varied.
У нас свои сценарии нормы, и каждый
Now, obviously, for every device, we have our own normal scenarios, and for every device, therefore, we have its own norm. So the total volume was 3 gigabytes, meaning that, in the ultimate data set, we had an average of 150 megabytes per device.
Спасибо. Перейдем к обучению моделей. Вначале
Now let's talk about model training.
наш набор на данные по устройствам, так как мы планируем.
Actually, we had to start by splitting the data by devices because we needed this individual profiling. So it's 80-20 split. 80% goes to training and 20% remains invisible for the model so that we can test the model afterwards and see if it's effective or not.
обучающих на 60 и 20.
Also, this remaining 80%, we split into 60 and 20 for training and validation purposes, respectively. We also go through fourfold cross-validation. Well, because we do have a different number of examples of different types of traffic for different devices, and we want every model to choose its hyperparameters individually, the right hyperparameters where it's going to perform the best. We have selected parameters with a random search.
Выбирается итоговый наилучший набор. Ну и, собственно, сами модели — это
And the models themselves,
мы используем
for classification purposes, we use the ensemble of random forest XGBoost and CatBoost. For classification purposes, like I mentioned, and for anomaly detection purposes, we used isolation forest, elliptic envelope, and one-class support vector machine.
Рассмотрим, собственно, результаты.
Now let's talk about the results.
Что задача обнаружения аномалий была
Anomaly detection
для устройств, для которых были примеры
is something that we were only able to do for the devices for which we had
обнаружения аномалий для устройств.
examples of attack traffic.
Нам бы не на чем было
For obvious reasons,
получать какие-то метрики.
we would not be able to test it.
На слайде также представлены далеко не все устройства.
Moreover, you'll see that I'm showing in a bright table here. Optimization of hyperparameters was based on the F measure. So we selected the based model depending on the F measure.
Что каждая модель из 6
Also, please note that each model out of the 6 proved to be the best one for at least one task, for at least one device. And on average, you'll see that the average F was around 0.98, which is a very good result, comparable to what you get in other studies. We actually believe it has a good upward potential even.
На конкретном примере конкретного устройства будем смотреть наши результаты
So we'll be considering
моделей обнаружения аномалий и классификации.
the results of this model for the following devices. Now, Philips Hue Bridge is a system hub for Philips Hue smart lighting system. Now, if such a device is compromised,
Но по факту
well, the lights will not go on, or probably will not go off.
индикации, например, на этих
But, for example, if you've got some indication scenarios associated with this lights, for example, motion sensors. Now, this can potentially translate into more serious issues.
управления светом при компрометации данного устройства есть
Now, if such devices are compromised,
авторы
and in fact, there have been articles mentioning this device in particular, that the researchers have been able to compromise the light bulb, making the light bulb blink, and the user would think it's effectively broken and would reconnect to a hub. When
со своей лампочкой
the researchers would propose, their own device to be used, and this is how they compromise the hub, and then they attack the internal network. In other words,
хуже не будет.
it is best to secure any device you're running.
Датасет
You won't regret it.
на-
So the data set that we have for Philips Hue
для этого устройства у нас есть 11 сценариев всего.
contains a total of 11 scenarios, including 2 malicious ones. These were imitations of flood TCP and flood UDP attacks.
Получается 980 тысяч примеров.
So the total is 980,000 examples.
Что на диаграмме довольно сильный дисбаланс, но
You will see that the diagram is
у нас
out of balance. But as Dmitry has already mentioned,
в своем нормальном поведении не генерирует так много.
it is only normal, because under normal conditions, these devices do not generate much traffic,
Сохраняется
unlike when they are attacked.
природа вот этого трафика, что у нас
So despite the balancing,
атака типа DOS, она будет преобладать по количеству по нормальному.
quite naturally, we still have more examples associated with attacks.
Этого этого устройства
So the best models we found for this device were cat boost for classification and elliptic envelope for anomaly detection.
метрики эффективности показывают довольно высокие результаты. Это 999
So efficiency and performance metrics show pretty good results. So triple nines for classification and 0991 for anomaly detection.
выводы о применимости
All this tells us that such methods can be effectively applied
хороших результатов.
in real life.
И перейдем к тому, что строит наш последний этап. Это
Now let's look at what's happening in the last stage.
анализ эффективности и так далее. Это первый этап представления эффективности моделей.
So the first stage shows the comparative efficacy of the models.
Какие именно классы модели определяют.
This report shows what kind of classes models are good and not so good at detecting.
Тут, например, мы видим, что наша
Here, for example, you should be able to see
отлично
that our attack classes are easy to classify. There are no classification mistakes. At the same time,
все остальные классы есть,
most other classes
которые допускают ошибки, но это не так
will
критично.
feature some mistakes,
Перепутать один
but they're not critical.
класс нормы,
I mean, when you confuse one normative class with another one, this is not a big issue.
F-мера здесь
You should be able to see here that the minimal F measure here is 0997 and the average is 0999.
Ну и всегда интересно взглянуть на матрицу ошибок, посмотреть,
Confusion metrics is always interesting to see
как
and
происходит.
see where the model gets it wrong and why, which classes it tends to confuse.
Данной матрицей мы можем сделать
So this particular matrix shows
сценарий
that
нормального трафика.
not a single scenario of normal traffic.
Вредоносного события не
Well,
было.
let me put it like this. Not a single scenario of a malicious event has been classified as something normal.
И
So there has not been a single false negative, and you will see that we have FPs and FNs only for scenarios of normal traffic.
перепутать
For example, the model can confuse Alexa on with Alexa off or a Google off scenario, which again is not critical for security purposes.
И для понимания решений модели мы строим, собственно, графики feature importance.
Now we're also building feature importance charts here,
Тот или иной
and they show
набор данных влияет на решение модели.
how much of an impact is a particular feature having on the output of the model.
Сделать вывод, что
So the conclusion you can make from this chart
наиболее часто фичей при решении выступает
is that the most common feature in decision making, so to speak, is most frequent port.
Я напомню, у нас
And out of this top 10 most important features, and you will remember that we have a total of 61,
которые были добавлены нами, эти
there are 4 that we added,
признак, например, TCP Window DNS и
such as TCP window DNS and packet trace NTP,
что показывает, что в
which shows
внесенные нами изменения и расширения в набор данных
that the changes we introduced, the expansions in the dataset that we introduced, have positive impact.
И перейдем к результатам
Now let's look at
задачи обнаружения аномалий.
the analysis of results for the task of anomaly detection.
Для устройства Philips Hue Bridge лучше всего показало
So for Philips Hue Bridge, elliptic envelope has proved to be the best model.
в Classification репорте мы можем
In our classification report, you will see that
метрика F1 это 947 тысяч
the lowest F1 metric is 0.947,
нормальных событий.
and this is, let me stress, for anomaly detection.
Ниже, чем прошлых, но нужно
Now you'll see that accuracy here is lower than for the previous category, but note that we have here a text like flooding,
можем определить эту атаку с самого первого пакета.
And with flooding, you will never be able to identify it as an attack when you just see the first packet. You know, you need some time to collect enough statistics for the model to be able to respond to it and identify it as flooding.
Можно видеть, что всего одно легитимное событие
In
идентифицировано.
the matrix, you should be able to see that, just a single legit event has been identified as malicious, and about 4,000 events were erroneously identified as legit.
График важности признаков. В данном случае уже 4 признака, введенных нами, влияют.
So there are 4 features that we introduced are important enough to be among the top 10 in terms of feature importance, which I think is yet another proof that what has been done here is actually useful. And we can actually increase the efficiency of models this way.
Перейдем тогда к сравнению с...
I suggest that we turn now to a comparison with other studies.
Заметить, что мы не можем напрямую все-таки сравниться с другими исследователями.
We cannot compare directly to other studies because what we are doing here is somewhat different. We develop individual profiles for each and every device.
Моделей для...
While most other studies have been focusing on device classes instead.
Был нами улучшен, расширен.
And we have improved and expanded the data set itself. So it's not really surprising that we have different results. We've got a different data set, our own markup, a slightly different set of features. So it's only natural.
Только максимальные полученные значения. Мы же...
Now, researchers usually quote only, the best results that they have, but we'll give you the whole hullabaloo. We'll tell you what the averages are and what the minimum values are. You will see that, we are, in some respects, we are ahead of the competition. In some cases, we've got a thing or two to learn from the other students or the other researchers.
Какие-то модели, которые не выходят в итоговую модель классификации или обнаружения аномалий. И показывают все равно довольно высокий результат.
You will see that, well, although not all models are shown here, we believe the results are quite robust. So this system has been integrated in an existing network already. I mean, it's operational, it's already doing traffic capture and feature identification. So all this stuff goes into the model.
Выходит ответ, то есть либо обнаружится аномалия.
And then, a response comes back. It's either, traffic classification or anomaly detection. And then operators can initiate either an anomaly investigation or decide to, say, retrain the model or update the model based on the reports. In other words, what we have developed seems to be a pretty functional tool for a security system operator.
Модульная, то есть
the system itself is modular, which means that you can deploy each module individually and independently. So the training, the development, the preprocessing components can be deployed separately. And such a system can also be integrated in a higher level system if needed. So I hand over to Dmitry so that he summarizes the report. Yes, thank you very much, Daniel. Let me also say about the system that the most important element here is iterative learning. Like I said at the very beginning, we cannot really expect devices like this to stick to the same behavioral profiles over time, which means that we need to track that. As, behavior changes, performance of the model can go down unless you react to that. And I've already mentioned how you can react. Like we said, a lot has been done, and a lot also remains to be done. And we are planning to continue our research. We are planning to expand our data set, to develop our own bench. We are happy to grab more data from other researchers. We are going to augment the feature space. We've tested some parameters for some models. We can test other models with other parameters. We are also planning to strengthen the part related to anomaly detection. So we are considering now, heavier, deeper, if you like, learning tools.
Всем большое спасибо.
And this is it. Thank you very much for your attention.
Вот, на слайде есть QR-код, который ведет в мой Telegram. Если у вас какие-то
The
дополнительные
QR code here will take you to my Telegram. If you have any questions for me or Daniel, both of us are open to discussion, and we will be happy to tell you more about our research and the system. Yes, thank you very much, gentlemen. Let's give him a round of applause. If you've just joined this track, I'll remind you that in order to ask your questions, you need to approach a mic. And we've got two in the room. One is over there, and the other is in the other part of the room. Yes, thank you very much for such a report, guys. While people are making their way to the mics, I'll ask my own question. So you show so many nines. What's your insight? So how many, false alarms and, false readings, so to speak, you had?
как раз фолзу мы показывали на матрицах ошибок, и вот
Now we did show the FPs and FNs with our confusion matrix, and we did such reports for all devices. For some devices, the figures were similar to what we showed. We actually chose to show you the most problem-ridden device. With the devices designed for fewer scenarios, there were fewer mistakes because, there are fewer functions and fewer attacks possible.
мы готовы поделиться, предоставить.
We are happy to show all the data that we have, but I can tell you that we actually showed the worst case in our presentation. Well, I do hope that people will approach you and ask you for the link to the article because it sounds like a great thing to read. Thank you very much for this report. Now, the data set that you have described seems to contain primarily DOS, scan, and flooding attacks, and they all require lots of packets. And that begs my question. Isn't it easier to simply calculate moving average with some trust interval for every device? And that will probably be the most important feature. Wouldn't it be faster and it would still tell you exactly with the same probability that DOS attack is happening? Yeah, let me field this question. Yes, that's a classic dispute about why would we want ML if rules work so well already. And that's a very reasonable point you're making. The only point I'm trying to make is that with our approach, we are learning what the normal behavior profile is for a particular device. And it's still debatable whether this can be applied to the whole device class. Our system, if it relies on rules, will work faster for sure. But if things change, it will be more difficult for us to adapt. But if we're using ML, we teach the model based on our pipeline. It develops the statistical profile and the thresholds. So it is more adaptive. And with proper iterations, it will stay up to date. So the big question here is, what is easier for us, to automate the pipeline with ML or invite an expert on a regular basis who will update those thresholds? I want to argue with you on that point. So you're saying that you're just retraining the model every time you realize that accuracy is going down. You know, with statistic characteristics, you can just go for 3 sigmas or a quantile, and then dynamically the model is going to adapt to the changes in the network as a whole. And this way you will continue registering your DOS attacks. I suggest that we continue this argument off the stage. Shall we? I see what you mean. It could be an interesting discussion to have. I do believe it's a very interesting point. Something you would probably want to add to your comparison table. Because, you know, in commerce, we often use a baseline where we say that, you know, this is the least you should have in ML to make it feasible. Yeah, there are in fact different types of DOS attacks. Not all DOS attacks are fast. So detecting everything through spikes alone is not always feasible.
Вам не показалось то, что точность у вас, ну вот F1 мера слишком большая?
Don't you think that your F1 measure is way too high? I'm thinking that it's so high, it may be indicative of an issue with your dataset.
Понимаем вопрос.
I see where you're coming from, sir. Indeed, it is only natural to believe that if metrics are too good, then the dataset must be too simplistic.
Различными сценариями нормы и различными сценариями вредоносной активности. То есть модели легко разобраться.
Вы понимаете?
Otherwise, why is it so easy for the model to distinguish them? Well, you seem to be using very simple models and they give you very high accuracy. So it sounds like you have an issue with your data set.
Плохие атаки, вообще вот эти ЦИЦ датасеты, они плохие.
So I'm trying to say, are you sure your data set is okay? You know, it's an artificial data set. It contains few devices, very few attacks. These attacks are similar. Yes, we understand the point you are making, sir. And we are using this particular data set because that's the best one that's publicly available. We would love to work with real data set if you are prepared to provide us with one. We would love to use a different data set. Having said that, I can tell you that for different models, with different parameters, we have seen huge diversity in accuracy. It was as low as 30%. We spent quite some time optimizing and balancing and selecting the right features.
Получать хорошие метрики, но здесь пришлось немножко поработать.
So it was not that easy.
Еще какой вопрос?
Another question then.
Решается проблема, то, что вы переобучаете модель. Вы решаете...
So you're retraining your model.
Дрейф концепции. Просто может, как я понимаю...
And it's ultimately choosing between data drift and concept drift. Because data can behave differently over time. What are you going to do about the concept drift? That's a good question. Indeed, the data drift problem does exist, and we are somewhat addressing it. As regards concept drift, I think that's worthy of a separate exploration. Indeed, the changes in the device itself can be substantial. However, we are only looking at network traffic. If we're using, for example, NetFlow or PCAP data, you know, it's pretty fixed.
Если сам, собственно, формат пикап или NetFlow изменится.
We will need to adapt only when NetFlow or PCAP format change. Had we been parsing the payload, it would have been much more difficult. Because the stuff that goes into logs is mutable, so to speak. New types of events can pop up, but we are dealing with the network traffic. So that's a kind of a hybrid approach then.
Ну, надо понимать то, что вы работаете с поведенческим анализом, то есть им нужно...
So you're doing behavioral analysis on network streams, but in real life,
не конечно, они идут, нарастают потихонечку. И когда вы говорили про то,
you actually see something different, like there is a slow increment. Now you say that you've developed your own parser. And to me, it sounds like you are breaking these streams down
их скармливаете. То есть у вас атака получается во время.
And then you feed these chunks, which means that you can see and detect an attack happening.
Она уже произошла. То есть
But in real life, will that mean you will be able to only identify an attack after it has happened?
Мы как раз стараемся работать.
You were right at the beginning of your statement. We are trying to make sure that we register an attack over time before it ends, because we do have characteristics, we have attributes for a packet. So far, we've not been using timestamps, but timestamps will give us lots of statistics. So as we see, for example, incremental growth in traffic or incremental growth in usage of specific ports or in lags, that can lead us to, faster response. Actually, we had this case with a particular device where we lost like 3,000 events because, the ones that had to be detected as malicious because the system was sort of waiting for the critical mass. Hello. Name is Leonid. I'm a bore, so we can have a pretty long discussion. I've got 4 questions. Let's turn it into blitz. Give me 20-second answers if you're ready. Yeah, sure, should. So, did you adapt the Canadian data, or have you got any data of your own? Because I'm wondering, say, about package data, rough packaged in SSL, for example. We have adapted Canadian data set, and we're working right now on collecting our own. Okay. Now, let's assume that we have, test traffic and malicious traffic. And then for some device, we have only the malicious traffic. We don't have the normal traffic. What will your model tell us?
Будем знать про модель только вредоносное поведение.
If all we know is malicious behavior,
получается вредоносного поведения, и будем ее использовать, чтобы детектить отклонение от вредоносного, то есть когда ему хорошо.
We will be able to detect deviation from the norm, which will be normal behavior. Well, okay, I understand the question, the answer. So TCP and UDP flood, will it detect a Yandex station, which is flooding the system with NMTP requests?
Ну вот говорю, если на уровне признаков будет похоже на...
If at the attribute level it looks like malicious activity, it should be detected. And the last question. When will you release an Android application so that I can monitor my home network? Is that a rhetorical question? Thank you.
Давайте перейдем в правую часть зала.
Да, ребят, спасибо за доклад. Такой вопрос.
Thank you very much.
На тестовых данных только реальные данные или у вас там синтетика подмешана?
Is it just real data that you have in test data, or is there any synthetic there? Yes, we did say that for balancing purposes, we used ADASYN to generate synthetic data.
Примеры трафика атак, они все реальные.
But all attack traffic samples are real.
Насколько синтетика репрезентативна, к реальным данным?
And how representative is synthetic data?
Хотя бы какие-то.
Have you analyzed some static characteristics?
Можно сделать отсылку к тем методам, которые мы использовали. Понятно, что и ADASYN, и Random Undersampler, они
probably mention the following here.
По-хорошему, можно было бы какой-нибудь GAN использовать и сделать данные более близкие к реальному с точки зрения модели данных. Но здесь хватило достаточно простых методов, и, в принципе, трафик действительно...
We discovered that we could make do with pretty simple methods. Remember, this is IoT. The traffic for IoT is simple. The number of scenarios is really limited. Thank you.
Давайте, с левой стороны вопрос.
Question on the left.
Стас Рычков, спасибо, ребята, очень интересно.
Stas Ryczkov, thank you very much, boys. Great presentation. I really enjoyed listening to it.
У вас получилось, допустим, вы много...
I understand
получилось соотношение
that
false positive 4000 к 1, поправьте меня, если...
you have FP to FN ratio of 4000 to 1, despite your long-winded research.
после всего анализа, как синтезировать данные. Например,
Do you
если,
understand now how to synthesize data?
ну, например,
For example, if you have previously unknown devices,
как на основе того, что вы здесь научились,
say there are several hundred IoT devices in a car,
значит,
can you now synthesize data
правильную статистику по
to collect reliable statistics for devices you know nothing about?
Интересный вопрос.
Thank you very much for such an interesting question, sir.
Причем качественный.
Indeed, the task of generation of high-quality synthetic data
Сложная и дорогая задача.
is a very ambitious task, something that I would like to call a $1 million task. This is not something we have actually been using or doing much. We would probably use some, heavy GUT model to do that, but I cannot at this stage guarantee that we would be able to do that. I'm not sure there is a solution for that at the moment. So I do agree it's an ambitious task, but we're not doing that. If I may, if you have a limited data set, you can try simulating a situation like this, like train a model on n-1 device, and then see if it works on this extra device you have not included. And that would potentially be an answer to the gentleman's question.
Окей, продолжим с вопросами. Теперь с правой стороны, прошу.
Да, Дмитрий, Даниил, спасибо за доклад.
Dmitry, Daniel, thank you very much.
Скажите, вы говорите о том,
Name is Alexei.
что вы обучили отдельную модельку для или разработали.
You say that you've developed an architecture and a model for, or rather, in fact, many of them for different classes of devices.
Для определения этого
Do you have any ready-made tool for device type classification? In ACS, IoT, and industrial networks, active scanning is often completely prohibited. Thank you very much. Indeed, we do not need scanning because we rely on network traffic. All we need is a passive sniffer that will capture all the traffic, and depending on the markup, it will decide which device is which. Like I said at the very beginning, we have not included in the scope of our study device type and specific device identification. So we're looking at specific devices and their network traffic. Like we see that this particular device is associated with, say, Philips Hue bridge and so on and so forth. This is not something we looked at. As part of the scope, we knew what kind of devices were there.
Практического применения
Thank you.
прототипа нам же нужно как-то определять устройство. Есть идеи,
For an implementation of your prototype, we would need to identify devices. How would you do that? Well, if you have a system with IoT devices and you are prepared to share your traffic with us, we would be glad to train our models on this traffic and see if they're any good. This way, we would move from an artificial data set to a to the ground truth data set. One more question. You've mentioned application of different models to identify anomalous activity. What's the performance of your system?
2 гигабайта оперативки, 1 процессор.
So we often have this limitation of 2 gigabytes of memory and like 1 CPU.
Потребление ресурса и...
I wonder, in other words, have you measured the capacity and the throughput of your system? Thank you for the question. We have done those studies. If you send me a message, I'll share the details. I don't have the figures off the top of my mind. But generally, the requirements are not high. So you may remember there was a comment that we were using primitive models. Well, primitive they may be, but, they do not consume too much power. These are lightweight models. They don't take up much space. They consume little power, and they return results fast. So we can certainly squeeze it in 2 gigabytes of RAM, and you'll still have ample memory there to run your favorite games. And we have enough time for one more question.
Добрый день.
Неограниченное количество вопросов.
Спасибо за доклад. У меня вопрос.
Or at least one more person.
Вы когда разделяли датасет, вы учитывали...
So when you split your data set, you took into account the timestamps, right? Maybe you have such high performance because of a data leak? Maybe your model simply knows about the future? And this is a question, I guess. Yes.
Смотрите, мы временную метку именно модели не передавали, чтобы она не...
We did not give the model timestamps,
В какое время
so that it would not take this into account.
эта информация из датасета вычищалась, и в 61 признаке, с которым мы работаем, такой информации нет. В дальнейшем, когда мы данные делили, собственно, на подвыборки,
So when we were splitting the data into subsets, we would extract it randomly,
ну, насколько это было возможно,
and we balanced it across the classes as much as that's possible,
могла с ними работать.
so that, the model could rely on that. Doesn't that mean you were not able to avoid a data leak? So you have timestamp X, you gotta calculate your stats, and the important features such as, say, max packet size, number of bytes transmitted, you only have prior to that moment, right? So if you did random sampling, this means you also took data from the future. Wouldn't that mean a data leak?
Да, я не пояснил, мы когда...
I should have explained that. When we selected the time window, it was a time window in the past, not a time window in the future. So we're looking at what happened in the previous 20 time frames. So all the statistics was about the past, not about the future. Thank you. Thank you very much for such a convincing presentation.